Hi, this is Dr. Neil Barnard. Welcome to this module. Let me walk you through the objectives for today. At the end of this activity, the learner should be able to understand cultural changes in dietary habits that have been associated with increased risk of type 2 diabetes, describe the findings of it. Very often when people approach diabetes, they think about sugar and carbohydrates. That's understandable because blood sugar is elevated in diabetes, and so we imagine that eating sugar must be the issue. You may find that your patients say, I've been eating too much sugar, that must be what caused my diabetes, or maybe I've been eating too much bread, too many potatoes, too much rice. These are carbohydrates that turn to sugar. Well, let's take a lesson from Japan. In Japan, the dietary staple is rice. Rice is consumed for breakfast, lunch, dinner, huge quantities. And if you look at diabetes prevalence in Japan in adults over the age of 40, prior to 1980, diabetes was rare, 1 to 5% of the population. But what happened in Japan right around 1980? Fast food chains arrived with burgers and fries. Things like chicken moved from being just little tiny bits used as flavorings to being at the center of the plate. Fat in the Japanese diet increased not to the point where it is in the United States, but it increased quite significantly, while carbohydrate intake fell, meaning the Japanese population was eating less rice, more fat. And by 1990, diabetes was 11 to 12% of the population. Diabetes is not primarily a genetic disease. Between 1980 and 1990, the genes didn't change. What changed was the environment, particularly diet. Let's take a lesson from the United States. If you look over time at U.S. Department of Agriculture figures, you see this striking rise in meat consumption that peaked in 2004 at 201.5 pounds of meat per person per year. The rise was particularly acute for chicken. Americans now eat more than 1 million chickens per hour. Let me say a special word about cheese. Cheese consumption increased through the same period, and if you extend the graph out to the current year, we're at about 35 to 37 pounds of cheese per person per year. If you look at diabetes prevalence, it's changed as well. Here are some slides from the Centers for Disease Control and Prevention. And as you can see in the upper part of this graph across Washington, Idaho, Montana, North Dakota, Minnesota, this is the adult population. Diabetes was fairly rare at that time, and in disgrace was Mississippi, also Louisiana, where they had diabetes over 6%. But this was 1994, and as you'll recall, meat, cheese, chicken, all going up during that time. So here's 1995, 96, 97, 98, 99, 2000, 2001, 2002, 2003, 2004, 2005. Diabetes doesn't wait. When the diet changes, diabetes comes roaring in. Now, the colors were all changed by the CDC in 2006 so that you could zero in on specific counties. But as you can see, the colors are still changing and diabetes is coming to roar in. Now, the colors changed again in 2010, but it's much the same phenomenon. So, who does better? In 2009, the Adventist Health Study data were published. This was a huge study centered in Loma Linda, California, focusing on people who were Seventh-day Adventists, nearly 61,000 participants. Church teachings recommend being health conscious, and diet is a huge part of that. So there are many people in the Adventist community who follow vegetarian diets or vegan diets, and many others who don't. And this sets up a wonderful natural experiment. Looking first at body mass index, the researchers separated the participants into 5 groups based on the diets they normally followed, and the non-vegetarians in the groups. That is, people who ate meat on a more or less daily basis. They did not have a body mass index below 25, which is where we'd like to see it. Their body mass index was 28.8. And then The semi-vegetarians, that's meat but less than once per week. They were a little bit thinner. Pesco-vegetarians, meaning no meat at all except for fish. A little thinner at 26.3. Those participants following a lacto-ovo-vegetarian diet, that is, they didn't consume meat at all, but they did have milk, which is lacto, and eggs, which is ovo. Their body mass index was lower than the meat eaters, but still above that 25 where we would like to see it. Now, the vegan group. I often have to tell my patients that a vegan is not a person from the planet Vegas, but there were people in the Adventist Health Study 2 following a totally vegan diet, meaning no animal products at all. Their body mass index was 23.6, meaning they were actually the only group smack in the middle of the healthy weight range. But the reason that the researchers published these data was not so much body mass index, but diabetes prevalence. It was highest in the individuals following a non-vegetarian diet, 7.6%, very much like the rest of the population, and lowest in those individuals following a vegan diet, 2.9% of the population, extraordinarily low. So my research team said, why don't we try that diet as a randomized trial, including people who never thought about making this kind of diet change before, but let's see how it works. We brought in individuals who were overweight. It was 64 women, all over the age of menopause. They had done every kind of diet you can imagine. They had lost weight, regained, lost again, regained weight. And in this case, we asked them to follow just two rules. First, no animal products. So it was an entirely plant-based diet. Secondly, minimize oils. So for all of those people who were taking their big bottle of olive oil and going glug, 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 glug all over their salad or all over their pasta, we asked them not to do that. We taught them non-oil cooking techniques. We asked them not to change their exercise habits because we wanted to zero in on diet alone, and it was a 14-week study. We had a control group following the National Cholesterol Education Program diet, and that basically means a diet that reduces fat, reduces the amount of meat, favors white meat over red meat, and was generally thought of as a conventional heart-healthy diet. That was the control group. For the people following the plant-based diet, we asked them to follow the power plate, focusing on fruits and grains and vegetables and legumes. And we remind our participants that legumes are foods that grow in a pod, like beans, peas, lentils. A typical day's meals actually might have horrified our participants a little bit because they had imagined that things like pancakes or oatmeal filled with carbohydrate might make them gain weight. But nonetheless, we suggested that they have things like pancakes without the butter, or oatmeal without the cream, but topped with cinnamon and raisins. They could have a half a cantaloupe, or if they wanted to, they could actually have the whole cantaloupe. There was no calorie limits, no portion size limits. If their linguine arrived, it wouldn't be topped with meat sauce or Alfredo sauce, but might be topped with artichoke hearts and seared oyster mushrooms. At 14 weeks, the average person had lost 13 pounds. We checked their insulin sensitivity with glucose tolerance testing and found that it significantly improved. And we tracked them for an additional year, finding that they continue their weight loss. And then we tracked them for a second year and showed that they actually maintained their weight loss for 2 full years beyond the initial period. Other researchers have done similar tests, looking at different kinds of diets to see how they compare. A research study done at Tufts University brought in 160 participants and assigned them to 4 different diets. One was a low-carbohydrate Atkins diet. The second was a macronutrient balanced diet following the Zone approach. The third was a basic calorie restriction following a Weight Watchers approach. Fourth was a low-fat vegetarian diet following the Ornish approach. As you know, Dean Ornish has advocated a low-fat vegetarian and sometimes vegan diet for patients with various conditions. His heart study used a vegetarian diet, meaning it eliminated all meat and eliminated dairy except for 1 cup of non-fat dairy was permitted and egg whites were permitted. So that was the approach, I believe, that was used in the Tufts study. When you looked out after 12 months, what you noticed is that there wasn't a significant difference between the groups. They were all fairly close. Everybody lost weight. However, there wasn't any benefit at 12 months for following that low-carbohydrate Atkins approach. The people on the Ornish approach actually lost the most weight at 6.6 kilograms. Pretty impressive. So Why do you lose weight on a plant-based diet? You're not limiting calories. You're not limiting carbohydrates. So why do you lose weight? Well, the first reason is that we are reducing energy density. Every mouthful has fiber in it because it's vegetables, fruits, and whole grains and beans. Everything you're eating is from a plant. Plants have fiber, so you're getting lots of fiber in your diet. Fiber has effectively no calories, but it tends to fill you up. When you eat high fiber foods, it feels very filling, and the fiber actually holds a little bit of water, almost like a sponge, and that makes you think that you've eaten a huge amount of food, even though you're eating less than you were eating before you adopted this kind of diet. The second reason people lose weight is, remember, there are no animal products in this diet, so there's no animal fat. If we keep the oils low, there's not a lot of any kind of fat. That's important because fat has 9 calories in every gram. If you compare that to carbohydrate has only 4 calories per gram. So while people are eating less fat and more carbohydrate, the density of the calories in their diet is diminishing. So we call that reduced energy density. Let's look at where the fat comes from. The leanest beef is about 29% fat. Let's say I think, well, I want to cut my fat content. I'll switch to chicken. Well, skinless chicken breast is not a lot lower at 23%. Fish, they vary all over the map. Tuna, 16%, Chinook salmon, 52% fat. Well, it's good fat, you might say? Not necessarily. Omega-3 makes up some of the fat in salmon, but that's not most of it. 70% or more is not omega-3. And every fat gram, as you'll remember, has how many calories? That's right, 9 calories in every gram. So if Chinook salmon is 52% fat, it's a lot of fat and a lot of calories. Now, foods from plants, broccoli, beans, rice, sweet potatoes, very, very low in fat, and that means that they have a very low energy density. Cheese, I'm sorry to tell you, draws 70% of its energy from fat. Most of that is saturated fat, which, as you know, is linked to heart disease, and some research is linked to Alzheimer's disease, but that the fact that it's 70% fat means it's going to contribute to weight problems too. Researchers at Pennington Biomedical Research Center in Louisiana did an interesting test. They brought people in the other direction. They increased the fat content of their diet for 3 days. It was a 50% fat diet. And what they showed is by increasing the fat content of their diet, the mitochondrial function was impaired. Now, you remember mitochondria. Those are the burners inside your cells. They turn fuel into energy. And although many people think of mitochondria as being fixed, we just have a certain number of mitochondria in each cell, that's all you get. It's not like that at all. The mitochondria change. You can get more mitochondria, or the mitochondria can coalesce so that you have fewer mitochondria. It depends on your body's need for fuel. And what we're looking at in this graph is mitochondrial biogenesis. In other words, is the body making the mitochondria or not? If it's making mitochondria, you can produce energy. You're burning calories faster. But the high-fat diet, a 50% fat diet, cut mitochondrial biogenesis in just 3 days' time, meaning the body is producing fewer mitochondria, less energy production. A high-fat diet interferes with metabolism. Our research team has studied this by bringing research volunteers in. They lie down on the exam table, and we are assessing their metabolism. And they, of course, say, oh, my metabolism is low. When I was 14, I could eat anything, and I didn't gain weight, but now my metabolism must be slow. I just look at food and I gain weight. Well, we're going to test it. So what we do is they lie down on a table, and we cover their face with a plastic shield where we can actually sample the oxygen that they're taking in, the carbon dioxide they're breathing out. And with some fairly simple arithmetic, we can calculate how many calories they're burning minute by minute. And it may well be low, but then we give them breakfast. And the breakfast is a standardized meal of 720 calories in a liquid meal. And then their metabolism rises, and it rises for about 3 hours after the meal. Then they go on a low-fat, plant-based diet for 14 weeks. They come back in, we measure their metabolism again, we give them exactly the same test meal. But what we see is their metabolism is faster. not a lot faster, but about 16% faster for about 3 hours or maybe even more after the meal. So why do people following this diet tend to lose weight? Well, the high fiber content and low fat content means they're just not getting so many calories, but they're actually burning calories faster. So how does fat slow the metabolism? This is a muscle cell. And I'm showing you a muscle cell because your muscles are your big calorie burners. And there are mitochondria in there, and the mitochondria are hopefully producing body heat and producing energy. But you have something else. You have fat inside your cell. Now, doctors hate words like fat because it only has one syllable. So we'll call it intramyocellular lipid, but it really means fat inside your muscle cells. So if your lunch was a chicken salad sandwich floating in mayonnaise with a slice of cheese on top, and you followed it with maybe some greasy French fries, the fat can enter the muscle cells. Your intramyocellular lipid is increasing. When that happens, it interferes with your mitochondrial action, just as we saw at the Pennington Laboratory. So the lesson here is that fat in cells slows down your postprandial metabolism, your after-meal metabolism. So what if I start a completely plant-based diet? There's no animal fat in it at all. And if I keep the oils really low, the fat inside the cells starts to diminish. So the lesson here is that getting the fat out of your cells increases your postprandial metabolism. There's one other piece of this that I want you to be aware of. This is a theory, but it's one that's really getting a lot of attention these days. And it's the effect of the microbiome, the bacteria that live in your gut. Bacteria in your digestive tract produce endotoxin. The bacteria produce this endotoxin, and it can sneak into your bloodstream. At the bottom of this slide, you can see the endotoxin passing into the vasculature. And when it does, the question is, could that be interfering with my metabolism? Researchers at Virginia Tech wanted to test an important hypothesis, and it goes like this. Eating fatty foods, having a high-fat diet, could disrupt the intestinal barrier, allowing the bacterial endotoxin to enter the bloodstream. Or perhaps fat itself actually escorts that endotoxin into the bloodstream, and with the endotoxin in your blood, in turn, it can disrupt cellular metabolism. That's the theory. Is it true? They brought in individuals, gave them a 55% fat diet, that's a high-fat diet, for 5 days. And what they showed is, the first part is true. This is the amount of endotoxin in your serum, and it goes right up. In other words, a high-fat diet does indeed allow that endotoxin made by the bacteria to enter your bloodstream. And then, normally, when you eat a meal, your glucose oxidation rises. In other words, the mitochondria are oxidizing the glucose from the foods that you've eaten. However, what we see is something different after a high-fat diet. The first 2 bars are a meal challenge before anybody made any diet change. And as you can see, after the meal challenge, the glucose oxidation rises very nicely. That's the difference between the first bar and the second bar. That's normal. Then you start the high-fat diet, and what you see then is the meal challenge doesn't really change your glucose oxidation much at all. In other words, a high-fat diet impairs your mitochondria's ability to oxidize glucose. So it's slowing down your metabolism. My research team then said, okay, we already know now that a low-fat plant-based diet is great for weight loss. What will it do for type 2 diabetes? We did a randomized trial funded by the National Institutes of Health, and we tested a low-fat vegan diet versus what I'm going to call ADA guidelines. And let me define both. When I say a vegan diet, I simply mean a diet that had no animal products. When I say low-fat, I mean that we encourage our participants to not add fats and to avoid fatty foods like peanut butter or nuts. We also use the glycemic index to help people to choose the healthiest carbohydrate. If you're not familiar with the glycemic index, it's a way of separating foods that cause blood sugar to rise more acutely, like white bread, to separate those foods from, say, rye bread or pumpernickel bread, which are much more gentle on your blood sugar. The control diet followed ADA guidelines that were active in 2003, and that basically meant reduce calories to lose weight. It was a 22-week study, and it had a 1-year follow-up. And the main variable we were tracking was hemoglobin A1C. And if you're not familiar with A1C, if I were to track your blood glucose That's a good index of your glucose control at the moment we do the test, but it bounces around from minute to minute and hour to hour. Hemoglobin A1C is a measure of glucose that's gotten into your red blood cells, adhering to hemoglobin, and it's a good measure of how your blood glucose has been over the past 3 months or so. At the beginning, our participants were not below that hemoglobin A1C threshold of 7.0, which is where we like to have patients with diabetes. They were all around 8. The red line here shows the individuals in the control group on the ADA diet, and they did well. Their A1C dropped by about 0.4 absolute percentage points. That's good. Now, the people in the plant-based group, they dropped by 1.2 absolute percentage points, which is a huge drop, and that was just average. We tracked them over an additional year, and there was some give back. For the ADA group, they ended up right about back at baseline. For the people in the plant-based group, they did not. They still had a substantial benefit a year and a half out. When we tracked LDL cholesterol, bad cholesterol, it won't surprise you that it drops like a stone because you're not eating animal fat. When we tracked body weight, both groups lost weight, and there was not a significant difference between the two groups. However, what's remarkable about this is that the weight loss in the plant-based group was slightly better than in the ADA group. And that's important because the ADA group was trying to lose weight. They had calorie limits, and they were going hungry if they had to in order to hit their calorie limit. On the plant-based diet, our participants were encouraged to eat spaghetti and starchy foods as much as they wanted to, and yet they lost more weight. And that's, I believe, for the reasons that we outlined earlier. They're eating more fiber, so that helps them to lose weight. Their metabolism is improving at the same time. Let me walk you through the cause of type 2 diabetes. And I really think this is my most important slide. And I share this image with patients when I'm describing to them the cause of type 2 diabetes, because this helps them to understand why we're going to be using a low-fat plant-based intervention. This is a muscle cell, and I'm showing a muscle cell because muscles are powered by glucose. That glucose needs to get into the cell through those funny little purple doors, but it cannot get into the cell without the help of insulin. Insulin is like a key. The insulin key goes into that red receptor, just like a key in a lock, and when it does, it signals these channels to open up, allowing the glucose to enter, and here it comes. Now, if a person has type 2 diabetes, they've got glucose, they've got insulin receptors. What's not normal is the signaling. The signaling process isn't working, and the reason for that is fat. Those globs of fat, that intramyocellular lipid, that's coming from beef fat, chicken fat, fish oil, even vegetable oils. From the diet, they get into the bloodstream, they get into the muscle cells, they interfere with insulin signaling. And when you explain this to the patient and draw this on an 8.5 by 11 piece of paper, the patient will say, aha, can I get that fat out of my cell? So we say, yes, let's take out all the animal fat by avoiding animal products, and let's keep oils really low, and that allows that fat to dissipate. The same thing happens in the liver cells as well. There was an important study done at Yale University that I want to walk you through. They recruited 26 healthy volunteers, and they did a glucose tolerance test where they swallow 75 grams of sugar, and then their blood sugar and insulin levels are tracked over the next several hours. Some of the participants were insulin sensitive, meaning their blood sugar levels didn't rise so high. Others were insulin resistant. And they then tracked those two groups to see how they did. The insulin sensitive controls were young. They were 28 years old. They were thin, and their A1C was in a normal range. And the same was true of the insulin resistant individuals. They all had not done so well in their glucose tolerance test, and they all had a parent or grandparent with diabetes, but they were still young, reasonably slim, and they had an A1C in the absolutely normal range. However, the participants then all had MR spectroscopy, magnetic resonance spectroscopy, to measure the fat inside their muscle and liver cells. Looking at their intramyocellular lipid in the control subjects, there was not a lot of fat inside their muscle cells. But looking at those who were insulin resistant, you could see much more fat inside the muscle cells, and the same was true in the liver. And then when we look at the mitochondria, the mitochondrial activity is suppressed in the insulin resistant subjects. So this goes back to the data that we showed earlier. Fat builds up inside the muscle cells, and the mitochondria no longer work so well. I showed you the results from our own study of plant-based diets for people with diabetes. Let me now show you a meta-analysis where we looked at every study that had been done using plant-based diets and checking their effect on hemoglobin A1C. If you're not familiar with these forest plots, each line is a study, and if that little black square is to the left of the zero line, that means A1C got better, and as you can see, the results are very consistent. In every study, you see improvement. Now, let me also show you meta-analyses of body weight, and we'll also look at blood pressure. This is every study done using plant-based diets and looking at body weight. And now we've had to move the zero line to the right because every study shows weight loss. This is blood pressure that is systolic, diastolic, and as you can see, again, fairly consistent. When people go on plant-based diets, their blood pressure drops. The exception would be if somebody's blood pressure is already low and they're not on medication. At that point, you may not see much real change in their blood pressure. There has been a lot of effort to understand the causes of diabetes, and one hypothesis has been that it's caused by soda. And this idea did get some support from a meta-analysis published in BMJ in 2015. Researchers looked at the use of sugar-sweetened beverages and found that indeed, people consuming the most sugar-sweetened beverages had an 18% rise in their risk of diabetes. And if you adjust for adiposity, it was still significant. If you looked at artificially sweetened beverages, though, we found something curious. The artificially sweetened beverages, it seemed, or at least were associated with it, and this was true also when we adjusted for adiposity. Well, what's going on here? Let's look at a meta-analysis that looked not just at soda, but at all sugars, whether they might be in fruit or in cookies or sugar candies, wherever they came from. Looking first at total sugars, if you look at the forest plot, that little green diamond at the bottom, meaning that sugars seem a little bit protective. Now, it's not statistically significant. It's not suggesting that sugar reduces the risk of diabetes reliably, but it certainly doesn't seem to be associated with an increased risk. Looking now at fructose, we see much the same sort of thing, really not much different from one. If we look at sucrose, table sugar, there actually is a significant reduction, meaning that those people consuming the most table sugar actually had the least risk of type 2 diabetes, and there it was statistically significant. So if you put it all together, what we're seeing is that those people who consume the most sugars don't really have any increased risk of type 2 diabetes at all. Well, why is it that sodas would cause an increased risk and sugar in general doesn't? I'm going to suggest that sodas come with cheeseburgers and French fries. In other words, yes, sodas are associated with higher risk of diabetes, but it could well be that it's not the soda that does the damage. It could be all the other foods, especially fast foods, that come along with it. And if you look at a fast food meal, there is a soda in it, but there's a whole lot of other things to be concerned about. So for now, we are not recommending that people consume extra sugar. It's a good idea to limit it. It's unnecessary calories. You don't need it. However, they're not the only part of the diet, and it may well be that it's the other parts of the diet that are playing a big role in diabetes risk, packing that fat into the cells and interfering with insulin sensitivity. If we look at sweetener consumption overall, it peaked in about 1999, which was the year when water bottles really started to take over from sodas, and people have been consuming less and less soda, more and more bottled water. If that's the only thing we're paying attention to, if all we're thinking about is sweetener consumption, we're really missing the mark. Sweeteners are already dropping. It's important to also think about the burgers and the fried chicken and the cheese. Those are big contributors to the diabetes epidemic. I'd like to share with you an interesting experience that we had working with Geico, the car insurance company. Back in 2006, I was talking with their health director, who mentioned to me that they had about 2,500 people at Geico in just this one facility in the Washington, D.C. area. And they certainly had a lot of diabetes and weight problems. And we talked about doing a clinical trial, not here in our research center, but doing it at Geico. We brought in individuals. We asked them to follow a completely plant-based diet, and we tracked their body weight. We tracked their hemoglobin A1C. If they had diabetes, they did remarkably well. So at that point, Geico invited us to do a trial in 10 different cities all around the country. So for all those people who imagine, 10 different cities, You can't do a plant-based diet in Dallas or it'll never work in Macon, Georgia. Well, we put it to the test. What we found is that when people followed a plant-based diet, and what I mean is eliminating animal products and also keeping oils very low, if they did that, their weight dropped. And when we tracked hemoglobin A1C in individuals with type 2 diabetes, it improved as well. We then did a neuropathy study. By that I mean individuals who had had diabetes for many years to the point where it was attacking the fine nerves, particularly in their extremities. Typical case is a person who has perhaps some numbness, but they also have pain. It can be pins and needles or a stabbing pain. And in some cases, they would describe the pain as being much worse at night. If the sheets would touch their feet, it was excruciating for them. And as you can imagine, this doesn't just affect your feet, it affects your mood because you just feel like this disease is getting the better of you and it's never going to get better. We brought in 34 men and women. They were aged 18 to 65. They all had diabetes, long-standing diabetes. They all had neuropathy. The experimental group followed a whole food plant-based diet. We also gave them vitamin B12 because vitamin B12 is important for nerve function. We had a control group that got the very same B12, but no diet change. And the way we track nerve function is we look at the sweat gland function. This is a function of your small nerve fibers, and we have a metal plate that you simply put the palms of your hands on, and as it touches, it can register the sweat gland function, which is an index of your small nerve function. We also ask them to take off their socks, and we do the same thing in the feet. And what we noticed was that in the control group, things got worse, which is what you expect with neuropathy. But in the people following the plant-based group, their foot conductance, their nerve conductance in their feet actually improved, meaning that the nerves are getting healthier. We then asked our individuals, are you getting better? Just tell us, do you feel better or not? And what we found is that the average person in the plant-based group rated their improvement as a 5, about 5. I'm moderately better. And in the control group, they said, well, I'm closer to a 3, meaning, well, I'm a little better. So whether we're looking at an objective measure, like their small nerve fiber function through the galvanic skin response, or just how do you feel, we do see that plant-based diets do seem to help. So a healthy diet is fruits, grains, vegetables, legumes. We don't worry so much about portion size as long as what you're eating is really healthy. And we're also going to keep oils really low and focus on whole, unrefined foods to the extent that we can. So in summary, plant-based diets are associated with, thank you for being with me.